Hey everybody. So we are in biology for health science. And so for everyone who's kind of, working on this for your nursing degree or your pre-med program, this is for you. So this is just a real fast and dirty of how to do a dosage calculation for like a bio lab, right? So we're going to talk a little bit about the basics to consider some of the biometrics that you are going to want to consider. And then I run through a couple of examples, and I have a really nice worksheet, especially if you're in one of my classes from. So first, let's talk a little bit about the idea of dosages. So here's a dosage chart for children and infants. And like the reason I wanted to show this to you is because if you'll see, like based on weight or based on age, we have a different overall dose that we would be administering to this particular patient, right? So they don't all get the same amount. And the reason is basically because of, well, a few things. Like number one, body size. Some people are bigger than other people, and that means they have more cells in their body and they have different metabolic rates. And so that means that too much dose could be really bad for this individual, but not enough could not treat the ailment or the issue that we're trying to medicate for in another size or a differently aged individual. And then even at that rate, hold on, let me clear that up. Yeah. Even at that rate, say you have, two people that are the same, weight and hold on, smiley face. All right, two people that are the same weight. Some of the things you might be wanting to consider is, is this person, 17 and this person 70? Or is, this person a high endurance long distance runner and then this person is just been hanging out with me all day watching stuff on the couch? So we need to kind of consider these factors. So we're going to do it in the simplest way possible, and that's really by biomass for the most part. So that's what most of the time we're looking at. As you can see, as in this case, both the biomass and the age go up, we're going to see an increase in the overall amount that we would be administering to the individual. And that's biologically appropriate, right? So for smaller people, they're going to need that smaller dose. So it's not toxic, but for larger individuals, higher metabolisms, maybe, we're going to need that higher dose, right? So that's just something that to keep in mind, especially with something like, acetaminophen, right? These types of products here. If you were to administer too much, you could really have a lot of trouble with, say, like liver damage, especially because that is one of the organs we know that there is an impact with this particular one. And the truth is, most medications, there are upsides and there are downsides, right? So you need to know what the things are to look for in this case, dosage and liver function, individuals who maybe have like liver disorders or are being monitored, that's something to be considering before choosing this as a, fever reducer, pain reliever. So it's just, something to kind of keep in mind. And then in an individual, say that's like, bigger up here, maybe they have a fever and it's reaching some pretty high temperatures, right? And you give them too little because you're worried about the liver instead of just enough. Well, maybe they have a perfectly healthy liver, and what the issue is now their body core temperature is too high, and so it's causing damage in a different way. So there's never really a safe way to play this except for just to get your math right. And here's something: if you aren't sure, don't just trust your superiors, go to multiple sources, right? People make mistakes. And so I, would every time do your own math, make sure you're sure, see what somebody else would say, and then maybe go check the manufacturer's website to see if you're right. So, that with some things like Tylenol, you'd probably be very used to it, but there will be times where you're probably going to administer different types of medications and you're not super familiar with it. So be careful with the idea of trust. It's different from knowing for sure, right? Trusting is just not knowing for sure and acting that you might just be doing the right decision. And knowing for sure means you've got some evidence. I would go for that. Science and medicine, right? That's what we do here. Okay, so there's a lot of this out here, but there are, and if you're in any of my classes, I actually have a copy of this. Um, from St. Louis Community College. And what they do is they have a bunch of these really great practice problems for dosage calculation, and they use tablets and they use oral solutions and they, so all of this good stuff. And there's also the answers on the other sheet. So it's just something that I think is kind of useful for practice. And I also feel that when you're doing things that are math based, you should really have the solutions on hand right away, because then you don't pick up bad habits. So, like, don't just do the whole sheet and think you're doing it right and then check it later. Do problem by problem and then check yourself, right? And so here's kind of how you would want to do this. So you're going to be using this like fraction equation, right? So there's a numerator, there's a denominator, and they're going to be multiplying in this very specific way. And the way is like just pretty much across the top and across the bottom, okay? You're going to usually cross out some units, but for the most part, you're going to be, in this case, we're going to finally be looking at milliliters, right? So this is like say an oral solution for that, for this example, okay? In this case, we have a patient and they are going to need 100 milligrams of something, right? So this in this case is diluted into like a really common dilution that's very similar actually to the acetaminophen, which is like usually like 160 for every 5 mils in the kids dose. But there's others, so be sure that's not always the same one, not the same dilution fraction. So in this case, what you want to do is you kind of start with this availability right here, and you kind of, you flip it basically. So you put the 5 milliliters on top, and then you're going to put the 125. So this is like what's dissolved into it. Sorry, it's terrible. Like I don't have like a super nice stylus on me right now. Pull grams here. And then you got to do it into what you want, right? So you need to give the patient totally 100 grams right here, and that's for just the one patient, the one, time. And so the first thing you can do is like, if you're cross the units and then, obviously you're just left with milliliters. So that's nice. That's good. And then the next thing you do is remember, you're just going to like go directionally across. So 500, and then you're going to divide it by 125. Okay, so what that's going to do is that's actually going to give you about 4 milliliters altogether, right? After you finish dividing it out. And so that's how much you should get. And so since this looks terrible because I wrote it, here's what it will look like on your answer sheet. It's a little bit nicer. Okay. And then this is like XML is just, how, think of X as like the unknown value. That's what they're really trying to communicate there, not like, I don't know, like a spreadsheet type or something. Okay, so let's get back to another one. So this is another one that I wanted to go over. And so this is also for milliliters. And again, there's tablets and whatnot on this worksheet. But since most of what we're doing in our class this semester is really, volumetrics based in dilutions, right? And so oral suspensions is what we would call that. You have another patient who is, they're like half the size. They're a lot younger. They're a lot smaller. So in this case, you're going to only be giving them 50 milligrams. But the thing is it didn't come from the same bottle. Now we have a different bottle. Okay, this is what they had for us at the pharmacy. They had this dilution where you had 80 milligrams per every 2 milliliters. So it's a little bit different, right? It's actually quite a bit higher, and that could be dangerous because now this person is much smaller, and so we wanted to be careful, right? So let's go ahead and kind of work this out. So the first thing you do, remember, you got to flip. So let's just draw this stuff out, just so it kind of helps, I think. And then I like to do the arrows that just go across the top for most of my students because it's just like a memory thing. So if you just do this for all of them to start off, just start your framework with something like this so that you know your logic flow. You don't have to make little decisions as you're calculating, right? You just know like, all right, I'm going to flip it. So 2 milliliters, and then over here is going to be 80 micrograms. And then let's see here. In this case, we're going to do, 50. It's like, where are we? 50 micrograms. And then we're going to only do that for one time, one patient. And so the first thing we do is, sorry, that's supposed to be micro. cross out those units here, carry these ones so we know it's still in the oral suspension, which we knew in the first place. But now 2 to 50 is going to be 100, right? And then that's going to be over just 80 times 1, right? So we're just going over again. So it's like 80. And so that's after we, actually divide that out in the calculator. And in my class, you always have a calculator for this kind of stuff. 1.3 no, liters of this suspension is all they get. So like a teeny tiny amount. And if you were to look at it, it'd be like a centimeter by like a centimeter square essentially is like the volume of a milliliter, right? So like maybe smaller-ish than most sugar cubes is how to think of it. So it'd be like one and then like a third of one. So I'll try to make a thin version. Oh, that went terribly. Okay, that's supposed to be the thin portion. That's the 0.3. And that's the like 1.0. Oh well. And so that's kind of what you're envisioning you should be able to see. And so this is another reason why I kind of want you to be able to envision what metrics like looks like. And let me actually get the nice typed up version. This is what you'd see on the sheet, right? It's nice and typed up. So again, I believe in calculators. Later. Why? Because humans are like really bad at basic math, and we do, especially anytime you get a point something situation or like a fraction going, your brain, when you add steps to problem solving, your brain chooses which information it wants to carry forward a lot of the time. And especially if you know somebody who like, they always know and they're like, I'm always right and I would be right and blah, 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 blah. I wouldn't trust them with a 10-foot pole and like, or trust them with a 10-foot pole. I would touch them with a 10-foot pole because they are wrong with that statement. So fundamentally, everything else they're doing has kind of, we talk about that word trust versus knowing, right? If somebody gets offended that you want to see the evidence, like maybe you should talk to somebody who doesn't get offended when you ask for evidence because they know how valuable that is, right? It's not like an ego issue. Okay, so please, 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 please remember that. And so again, if you're in my class, you'll have a little calculator and usually like there's like a menu and like there's a little menu thing and you can drop down on the test and it'll say like, you know, calculator, especially if you're doing the respondus. Okay, so I hope that was super helpful. Like I said, you can check out the rest of those sheets from St. Louis Community College. Here's kind of like where the PDF is there. Um, and I think it's super helpful. And these are very important concepts to understand and master and all of that. So in the next video, we'll talk a little bit more about things like the meniscus and just like metric in general, just to give you like a good visual in your head. And so, all right, well, I hope you're doing well. I hope this was helpful and have a lovely day. Bye-bye.